Hi, I'm Yunlong Xu from the University of Rochester, and today I'm going to demo tsupy, a Python library for climate network analysis. To analyze patterns in global climate, scientists model climate data as complex networks. A climate data set includes sensor measurements such as the sea surface temperature covering a grade. Nodes in climate networks are geographical locations characterized by time series, and ages represent the degree of correlation between the time series. Climate networks has been shown to be powerful tools for gaining insight on earthquakes, rainfalls, and other global climate events. In this demo, we will showcase how tsupy can assist with efficiently analyzing events such as El Nino. The common way for network dynamics analysis is to construct networks for each hypothesized time window and analyze them separately. Given a query window provided by a user, a correlation matrix is constructed by computing the pairwise Pearson correlation of all time series on the query window. Then, a user-provided correlation threshold can be applied on the matrix to construct weighted or unweighted networks. The current task in network construction is the problem of large-scale all-pair time series correlation calculation. In our priority work, we propose the tsupy, an algorithm for efficiently computing the exact pairwise time series correlation based on Pearson's correlation. By pre-computing simple and low overheaded scripts, tsupy can efficiently compute the exact pairwise correlations on arbitrary time windows at query time. For real-time data, tsupy proposes a fast and incremental way of updating the correlation matrix. Tsupy is a Python library that uses tsupy as one of its core functionalities. The API of tsupy includes the exact correlation matrix calculation and the dynamics weighted and unweighted network construction and the basic network analysis functionalities such as the transitivity computation. Tsupy is a Python wrapper for Golang library for efficiency purpose. The core library is an implementation of a suite of parallel disk-based and in-memory algorithms for exact and approximate correlation matrix computation. Tsupy library is organized in a modular and extensible way to accommodate new functionalities, such as clustering and community detection in a climate network.
Hi, I'm Jishu Liu from U of R. Let me show you how to use it. First, import package from tsupy. The package needs init function to initialize the data structure inside it, which will be stored in the memory. Then the user needs to read data from files. Read files by location will read all netctf files from a directory. The second argument is a file which lets the user specify a range of locations from the data size. There is a progress bar to show the progress for reading files. The user can know how many data are stored in the memory by calling these functions. getTimeSeriesLength function will return the number of time series. getTimeSeriesLength function will return the length of time series. The user needs to specify the size of basic windows before sketch. We set it as 30 in the demo. The time resolution is 1 day, so it means each basic window is about 1 month. Then the user can do sketch. It will take 1 or 2 minutes to be finished. As you can see, there is a progress bar below. It will print the time after it finished. The user then needs to specify the start position of the query window, the length of the query window, and the threshold. By given these parameters, the correlation matrix and the age-weighted network can be obtained by a single function. It will take only 2 or 3 seconds. Then, let's get the transitivities. Assume that we want 12 query windows, and we set the row value to be 0.5%. This code will collect the transitivities for 12 query windows. For each iteration, it first gets a weighted matrix with given parameters. I is the start position for query window. Then, user can call getTransitivity function to get the transitivity. The time for getting each matrix is about 2 or 3 seconds. The computation for each transitivity will cost about 30 seconds. All of this will take about 6 or 7 minutes to be finished. The user can use very simple Python commands to get the plot of the transitivities. We can get the plot here.